As part of merging data sets, we have two other functions. One is called as the cbind and one is called as the rbind. Now, if our intention is not to actually look for some keywords, like for example, if I'm not interested in saying linking to different data frames, one assuming to have a functionality as a primary key and the second one existing in some other data frame as a secondary key. I don't want to do that. I just simply want to merge two different data frames, knowing very well that every observation is actually matched or mated to each other and are standing on the correct place. And obviously in this case I would use a function like a cbind, that is column bind, and the syntax for that would be cbind the data frame 1 and comma data frame 2, and that is how we do the cbind. Obviously one thing you need to make sure is the number of observations in each of these should be similar to each other. That means if one has 10, the other also has to be having 10. If they don't have, you will get an error. Similarly, when it comes to managing rows, so if you have one data frame and the second data frame and you just want to kind of keep on adding the second data frame underneath the existing one, that is where you'll use row bind, that is rbind, right? And in this case you have to make sure the syntax remains the same, the object 1 and the object 2, that is the two data frames. But in this case you have to make that the number of columns should be identical, that is both of them should have similar or equal number of columns. That's the basic priority. Okay, now from here on we move to the next step, wherein we are going to talk about ordering operations, right? So we are going to understand how we could use a package like dplyr and use it for arranging your data or ordering your data, right? So I already have it installed in my system, so I'm just going to call it. So I have installed the package. So what I would typically do is first let me have a look at the data which I'm going to work on, and that is the empty cars data. Right, so I'm just going to say head empty cars. So incidentally I'm just interested in extracting the first 6 data, right? So it's a typical data of car related parameters or attributes, right? So I can do a filtering on this data by using filter, say summarize, and the summarize would work only when you are using the dplyr package, right? Because it's a functionality within that. Select, and I say group by, right? That's the syntax, group by, and I'm doing group by on empty cars. That's the object, using cylinder cyl, the gearing ratio, and then I want the stats to be shown for mpg. So the summarization basically has to be on these attributes: weight of the vehicle, gear, and whether it's an automated vehicle or a manual transmission. And what I want to do is avg, that is average mpg. So I'm just giving a name to this, right? So I want to display it as average mpg, and what is actually going to be computed is the mean value of mpg, that is miles per gallon, right? And second one is avg weight. So average weight is nothing but mean value of the weight. Okay, and then finally I'm saying that I also want one more thing, that is avg mpg, it's a condition greater than 15, right? So obviously I'm going to just wrap this over here and just give this as a final function call. Okay, so this should be gear.am, so I have to just make this comma. So you are basically looking at how do you filter the data and see it in this form, where you are basically doing a filtering on the data, selecting a group of data from the empty cars object by using some parameters, and the group by clause given is the cylinder and the weight, and you are specifying what stats you want to actually extract, and that's the mean value of the miles per gallon, average vehicle weight, and you're also giving a condition that the miles per gallon should be greater than 15. That's what is your specification. So only show me the data for those points, or show me the summarization for those points wherein the average miles per gallon is greater than 15. If you don't mention that, obviously let's try that also. So if you just remove this part right? So over here you will see that it's not limiting itself to something greater than 15, right? So that could be a scenario. Ideally the data doesn't have anything like that over here, and most of them are above 15. So basically both of them are giving the same output. You can do a little bit of tweak over here, and you can also specify, let's say for instance average mpg is greater than say 25. Let's try this out. Now what you have done is that you have specified that when you are filtering this data, make sure that the average miles per gallon is greater than 25. So it's only showing you those data points where it is greater than 25, right? So you can specify these conditionalities also when you're extracting, right? So this is one functionality which you would use, the filter, summarize and the select, all of them together by using the deploy-r package. Now incidentally you could use the same functionality in a chain of a function also. A chain function basically talks about how do you nest each of them within each other. The same thing which we have done here, we can show them in a different form, wherein I can say empty cars, right? You're mentioning the percent sign and you're saying greater than percent sign, and you're saying group underscore by, right? You just need to understand the subtle difference between these two. Incidentally it's doing the same thing, but the only thing is that you are doing it in a chain operation, right? That's the only difference. Otherwise the output, the end result would be the same, right? So I'm going to just copy this and not run it over here, because it makes more sense to run it in a script file wherein I can first type it in one go, right? And then I'm saying select mpg. So I'm creating something in the first line. From that I'm using again a reference point, and within that I'm extracting select mpg cylinder weight gear am. Again I'm allocating. You should look at the arrow sign, the percent allocation sign. The arrow sign is indicating that this is going to be used further, right? So it's kind of inheriting the object from the previous level. So mpg comma cyl comma weight. So frankly speaking we are using the same code as it is, but just that we are using it in an inheritance form. And then I'm saying, and also the readability of the code increases if you use this kind of a syntax, right? So it makes sense for a user, or he can understand what is really happening. So many people write codes, but if you write a code in a good or an optimum way, anybody else who joins the project later on can also understand what you intended to do. Otherwise it will just be a set of code which only you understand and nobody else understands. Average weight is equal to mean of weight, and again use this as an inheritance. So I'm saying percent allocation percent, and finally I'm saying filter basis avg mpg to be greater than 15, 12, whatever you prefer. So just on this, so the output remains the same, right? But this is a good way of working on the code, right? So the chain function basically makes it more readable, right? In the previous case when you had used the filter, summarize, select and all those things, a normal coder or somebody who doesn't have good experience in R programming might feel lost. It's a bit confusing, but this is more readable, right? Okay, so we'll move to the next level. So now we'll start using SQL statements to access a data frame. Now we have merge, concat and all these functions which typically work on a data frame. But what if somebody is from an SQL background? So people who are from SAS background typically find writing programs in C-based environment a bit difficult, but rather find it more easier to handle data within an SQL functionality. So for all those kind of people, R has an option, right? So you have a package called as SQLDF, which basically helps you to manipulate the data frames as if you're writing an SQL program, right? So we'll work on that now. So first thing which you'll require for this is a package called as SQLDF, right? So let's install that. So it's SQLDF. Obviously it's not there, so we'll have to install this package. Install that package SQLDF. So once this is open, we'll access this library and start writing some basic SQL statements, right? And then you have your help page, so you can go in your help page, wherein if you type SQLDF, you have a host of functionalities which are shown over there, which you can obviously explore at spare time. So this should take some time because this is installing the dependency file. So let's just complete this portion of installation of this package, and then we should be ready to hit SQL command based extraction of data from the data frames as if you're writing an SQL program. Okay, that's about it. So I'll just go and call the SQLDF package. So it's ready to be used, right? So it's installing or basically loading the dependencies. So now we'll start writing something. So I would like to access a package called as iris. So let's have a look at this data first. Data iris, a very renowned data set. So head iris, right? So this is the data: sepal length, sepal width, petal width, species. Basically it talks about a plant species and some measurements being taken about the length, width of the sepal and the petal, right? And based on that, it's basically a classification problem, but over here the intention is just to sort the data and just do some SQL programming. So let's go about it. So you have to use SQLDF, that's the function, right? You can allocate it to some object if you want, but right now we're just going to extract data. So you're saying select, right? So this is something which we know. Select star, that means select all the data, that means all the column from, and I'm going to access iris, that's the iris data set. Order by, basically saying order by something, and the columns have to be referred with the double quotes, sepal underscore length, right? Be careful about the names, okay? And then you say descending. So if you want to sort it basis a descending or an ascending, and you can limit the number of observations to 3, 4, whatever you want. So you're just extracting the data. So this is how the output would be. In fact, if you just remove this limit, it will show you all the 150 observations which are there in the data frame, right? Okay, so that's how we'll do the SQL.